Unfortunately, we are not computers. We cannot do this for loops. Okay, so we have to do it in an intelligent way. Okay, so how do we do this in an intelligent way? That's the question.
Hello, guys. Welcome to Cheenta's School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI Stat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
So let's look into this. How we can do it in an interesting way. Yeah, I'm taking some time to discuss single problem, but that's what we are here for. You want to understand it in details. What's exactly happening, right? So A and B are disjoint, right? How do we make this clear? How do you mathematically code it like A and B are disjoint? But how do you count it? That's the question. Can you take this similar toppling idea like this to count it? Yes or no? How did we get this subset counting idea? Let's see. We have A, right? So what they said is that if my element X is inside this, I give 1. If it's outside this, I give 0. That's how we did the coding. So now can we do a similar thing here? There are 2. Let's say there is another Y. So there is X from A and Y from B. Okay. So you have 2 elements out there. So essentially, these 2 elements will be telling you. So how can you use now 2 elements instead of 1 element? Am I making you understand? Initially you were counting. Initially you were counting just for one set. So there was only X. If X is inside, so essentially you are looping it over all possible 1, 2, 3, n. That is X. Now you're checking whether X is inside A or outside A. Inside A or outside A. That's where the 1 0 1 0 1 0 1 0 binary thing is coming. But now you have 2 things, X and Y, right? Now how can you count X? Am I making you understand? Am I being able to make you understand, guys? How can you make you understand? How can you make now? How can you do the coding? That's the question now. With X and Y both, there are 2 sets out there, A and B. How can you make the coding now with X and Y? That's the question. All of you understood the idea? We're generalizing to this. Yes. So now you have X and Y. How will you make sure that X and Y are inside, like they are disjoint? How will you make it sure? Understand this one thing very carefully. You want to count all the disjoint elements. So an element, understand this very, very carefully. So let's now, so these are the all possible A and B's, right? An element, let's say 1. We have to count it in terms of that. That is X, let's say. X ka kya choice hai? What are the choices of X? X can be inside A, but if X is inside A, it cannot be inside B, right? Because they are disjoint. Or X can be inside B, or X can be outside. The 3 possible choices, right? So you code it as X is equal to 1 if X is inside A, is equal to 2 if X is inside B, and is equal to 3 if X is outside, is neither inside A or neither inside B. It's outside. That means here it's 1, here it's 2, and outside it's 3. All of you understood it? So now suddenly everything makes sense, because every X has 3 options. Either it can be inside A, or either it can be inside B, or it can be outside A and B, because A and B are not disjoint, right? So let's do a color coding example. It's so elegant, right? So if you do 1 2 3 1 1 2 3, what does it mean? How? So you have to make a connection, right? Bijection. So what is A, what is B? So this should give a unique A and B. So if it's 1, 2, 3, 1, 1, 2, 3, it's like 1, 2, 3, 4, 5, 6, 7. Sorry, 5, 6, 7. Wait. This corresponds to 1, 2, 3, 4, 5, 6, 7. So therefore A is nothing but A is inside जो जिसमें 1 है. So 1, 4 and 5. जिसमें से 2 है, that is this one and sorry, this one and this one, 2 and 6. It's done. And outside is the rest, right? Others are the rest. So you can see it's clearly disjoint. Now just giving 1 and 2 will not help, because it is not told that A and B should be exhaustive. That means A union B should be the entire set. If it was told that A and B should be exhaustive, then you could have just done it with 1 and 2, right? Because an element should be either in 1 or B, A or B, right? Because it's exhaustive. A union B is entire. A union B is disjoint and A union B is exhaustive. So therefore, the answer is nothing but 3 for each of the 3 options for each of the A, and it's unique. You will never find it anywhere else. Or is it? Yes, it's unique, of course, right? It's always unique. Because this will give only another simple output, right? For this simple expression, you will get exactly the same expression back. So it's unique, always. So therefore, every A and B pair, or rather, yeah, the set is equivalent to one such coding of 1, 2s and 3s of an n tuple where each element is 1, 2 or 3. So therefore, in this case, each element has 1, 2 or 3 options, right? Do you think the answer will be 3 to the power 4? That is 81. No. The reason is this, that if it's 3 to the power 4, there's a problem. The problem is A and B are not ordered pairs. Okay? I mean, this, if you change it, they are still the same. It should be considered the same, right? Because it's not ordered pair. If B is 1, 3, 1, 4, 5 and A is 2, 6, it's not an ordered pair, right? But still you should count as the same thing. You can, that means in this 3 to the power 4 case, you're over counting. So you have to reduce that down. And also it's not even unique. It's not even 3 to the power 4. So what is the non-unique case that is there? That's the question, right? Which thing is not symmetric? Which A and B is not symmetric? Is there something wrong out here? Which A and B are not symmetric? Any ideas? So 81 is total number of options. We have to reduce it down to the case where A and B are not symmetric. Rather, has more elements than B, let's say, or at least equal to. We cannot divide by 2, right? Why we cannot divide by 2? That's the question. For which case we cannot divide by 2? There's only one case which is symmetric. A and B are the same. That is, both are phi. So that case we need to reduce. Because if we divide by 2, that will never be, because all other cases are asymmetric, right? Asymmetric in the sense that if you if you change A and B, there will be different representation. But in this case, if you change A and B, there will be the same representation, right? So you subtract that, 81 minus 1. Now it's all symmetric. Now divide by 2 and add 1. So 81 minus 1, so I think it's 41. All of you understood this? Simple, right? But yeah, we did a lot of hard work. So now my goal is to teach you a single problem from multiple dimensions, because that's what you will do for the rest of your life, right?
To book a trial class for your preparation courses of IITJM MS, ISIM Stat and CMI MSc Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.